Reversible cellular injury represents an early stage of damage where cells can recover if the stressor is removed. In this state, cellular damage is present but can be repaired if the stressor is removed in time. This microscopic image shows liver tissue with both normal hepatocytes and cells exhibiting hydropic change, a reversible form of injury characterized by cellular swelling. Reversible injury involves distinct morphological changes in cellular structures. These include plasma membrane blebs, mitochondrial swelling, dilated endoplasmic reticulum, overall cellular swelling, and clumping of nuclear chromatin. At the biochemical level, reversible injury leads to several functional disruptions within the cell. These include decreased ATP production, reduced protein synthesis, detachment of ribosomes from the endoplasmic reticulum, and activation of autophagy as a protective mechanism. Crucially, the cell maintains membrane integrity, which is what allows recovery if the stressor is removed in time. Reversible cellular injury manifests in several common patterns that can be observed microscopically. The most common patterns include hydropic change, characterized by cellular swelling due to sodium-potassium pump failure, causing water influx and giving cells a pale, swollen appearance. Another pattern is fatty change, where triglycerides accumulate in the cytoplasm, particularly in liver and heart cells that process large amounts of fat. Several key factors can cause reversible cellular injury. These include hypoxia, which reduces oxygen delivery to tissues, chemical toxins like medications and pollutants, various infections, and nutritional imbalances such as vitamin deficiencies. Importantly, if any of these stressors are removed before reaching the point of no return, the cell can recover and return to normal function. Irreversible cellular injury occurs when damage exceeds the cell's repair capacity, leading to cell death. These changes cannot be reversed even if the original injurious stimulus is removed. There are two major mechanisms of cell death: necrosis and apoptosis. These processes differ significantly in their causes, characteristics, and consequences for surrounding tissue. This diagram illustrates the key differences between necrosis and apoptosis. Necrosis involves cell swelling, membrane rupture, and release of cellular contents, while apoptosis is characterized by cell shrinkage and formation of apoptotic bodies. Necrosis is characterized by cell swelling, membrane rupture, and release of cellular contents, which triggers an inflammatory response. Key nuclear changes include pycnosis, nuclear shrinkage, karyorrhexis, nuclear fragmentation, and karyolysis, nuclear dissolution. Apoptosis, or programmed cell death, follows a controlled sequence of events. The process includes cell shrinkage, chromatin condensation, membrane blebbing, and formation of apoptotic bodies that are then phagocytosed without triggering inflammation. Let's compare the key differences between necrosis and apoptosis. While necrosis results from pathological injury and causes inflammation, apoptosis is a controlled physiological process that doesn't trigger inflammation. Necrotic cells swell and rupture, whereas apoptotic cells shrink and maintain membrane integrity. Several critical events mark the transition from reversible to irreversible cellular injury. These include massive calcium influx and profound ATP depletion. Massive calcium influx activates enzymes that degrade membrane phospholipids and proteins. Meanwhile, extensive damage to mitochondrial membranes and profound ATP depletion prevent the cell from maintaining essential functions. Once these critical thresholds are crossed, the cell reaches a point of no return. Membrane damage becomes extensive, lysosomes rupture, releasing digestive enzymes, energy production collapses completely, and cell death becomes inevitable.
If you enjoyed this video and would like to practice your understanding, go to MatEazy.com. There, you'll find this lesson outlined and divided, with a short quiz to see how well you really understood it. And if you're hungry for more, we've got piles of other topics for you to explore. Start learning easier. Visit MatEazy today.